Okay, so the quiz question goes like this. The height of the triangle is 4 more than the base. And area 96. So, okay, so those are the basic facts, right? So I just took the sentence, height is 4 more than base. Oh, it's not plugged in. That's always a problem. Maybe that'll help. There it is. All right. So height is 4 more than the base, right? Height is 4 more than the base. Height is 4 plus b. Everybody get that one right there? What's the area of a triangle formula? Yeah, a half times base times height, right? Area is a half times base times height. And so then we take this right here and plug it in for h, don't we? Everybody good with that? Sure. Yeah, you want to take it outside in the hall? One of the desks out there? Yeah, any way you can out there. That'd be fine. All right, so let's plug that h in there. And then the area is 96. Plug that 96 in there. And that's 4 plus b. We good to there? Does that make sense how that works? So I just plugged in for the h, the 4 plus b, because that's what h equals. That's what h is. 4 plus b. Good. And the area is 96, like that. All right, and now what do we do at this point? This is a lot of people get to here and sometimes get stuck. What do we do at this point? Yeah, by 2 to get rid of that half, huh? Because fractions are a pain. We just need to get them out of there, huh? So yeah, that's totally right. Multiply both sides by 2 and it's gone, like that. Yeah.
Could you just make the formula 2a equals space times height?
Yeah, that'll work too. Good thinking. I like that. You're thinking right about that stuff. Yeah, good. So this would be 192, 182, yeah, 192, huh? And then b, 4 plus b, like that. Good. Just got rid of the half, and the 2 times 96 is 192. Okay, now the b distributes, right? So 192 is 4b plus b squared. We good? All right, I'm going to bring it up here. So 192 is 4b plus b squared. What are we supposed to do the minute we see b squared? Get a 0, right? Everybody good with that? As soon as you see b squared, get a 0. Get a 0. So, right, like a knee-jerk reaction. Okay, so subtract the 192 from both sides. So there's our 0. Put these in the right order. B squared plus 4b minus 192. Yeah. Good? And now we have to factor. That's a pain. 192. You get 2 parentheses, b's in the front. Couple of numbers that multiply to be 192 and add or subtract, to be the 4, right? So that's a big number. So what you take your calculator, huh? Take 192 and you start just dividing by different numbers on your calculator. Did y'all get that? Did you figure that out? Just divide by, you can start with 2 if you want. It's going to take a long time. It's not going to work for a while. Divide by 2, divide by 3, divide by 4, divide by 5, divide by 6, divide by 7. Every time you get what would this be? This would be a 96. And 2 and 96, can they make 4 in the middle? No way. Then you just keep going and going and going. Eventually, I'll just go dot, dot, dot. Isn't it like 12 and 16? You got to remember it. So 12 and 16. So you divide by 12 and you get 16. You go, oh yeah, 12 and 16, they can make 4 in the middle, can't they? So that's your pair. And you don't even need to mess around anymore. Those are the answers, huh? 12 and 16. You don't have to do the parentheses and all that. It's going to be 12 and 16. So those are the answers. That was answer D, 12 and 16. Is that good? Questions on that? We okay? Anything I can answer on doing that? Triangle ones? That's not on today's test, but that's on, whenever the next one is, next week's test. Exam 4. All right. Well, before today's test day, you know that very well. Last hour we'll take the test, which is 12:30 to 1:30. So we'll take the test about 12:30. Until then, we got to get through chapter 6, and we have a. Okay, so there we go. So our question is 24 y to the 8th over 64 y to the 5th. And so we want to simplify. So chapter 6, we're starting chapter 6 here. In fact, we're going to do 6.1, 6.2, 6.3. We're going to do like a third of chapter 6. And it is, chapter 6 is all about rationals. Rationals, that's a fancy word for fraction. Ratio, one thing over the other. So this is the fraction chapter. This chapter is going to get ugly tomorrow. It won't be too bad today. Today's stuff's pretty easy. Tomorrow you'll see a lot of, it's going to be a mess tomorrow. So, all right. So is that an encouraging word? I'm not being very encouraging. But you can do it. You can do it with some work. All right. So what do we do for that 24 over 64? We need to simplify. You know how to do this now. You can do this without me saying anything. What do we do with the 24 over 64? Divide, huh? Yeah. Just use your calculator. What goes in? 2 goes in for sure. Probably 4. Probably even more, huh? 8. 8 be better. Yeah, I'll just do 4, and then I'll do some more. 6 over 16. Right? I'll do the y's in a minute. And then 6 and 16, I can go 2 again, huh? It would have been better just to do 8 right from the beginning, huh? That would be 3 over 8. So 8 from the beginning would have made it quicker. And now what do I do about the y's? What do you do when you got a couple letters vertical like that? Subtract, huh? That's on today. That kind of stuff is on today's test. So, and as the answer, the y to the third, it's going to be on the top, isn't it? Because the bigger power is on the top. So 3/8 y to the third. That's good. Hey, what if they put the y to the third in the front like that instead of in the top? Is that the same or is that different? I hope you know it's the same, because anything alone is over 1. To be alone is to be up top. Either way. So and the reason I say that is on the multiple choice test, either one would be great. Grab it. Don't be afraid to grab it. You know what I mean? So that makes sense. Remember, to be alone, like y to the third out front, alone, is to be in the top. Because if you're alone, you're over 1. You're the same as being in the top. That makes sense? Anytime something's out front alone, it's the same as being in the top because it's over 1. When it doesn't look like a fraction, it's really over 1, right? Good. Good on that, right? So just divide top and bottom, subtract the powers. Easy for you, right? These first 2 sections will be real easy for you, I think. Keep going. All right, number 3 here. We've got, this is question 3, 6w minus 54 over 6w. Got to reduce it. Got to reduce it. So what do we do to reduce them? Can we just cancel out the 6w's? Do you know the answer is no? Why not? Why can't we cancel 6w's? It's the minus sign. That's what wrecks it. When you have pluses and minuses, so here's already we're at an important issue for this chapter and the rest of the course. Pluses and minuses glue things together. They kind of like attach them so that they're all or nothing. Do you know what I mean? Like if I want to cancel, plus and minus things, if you want to cancel them, you got to cancel the whole thing or nothing. It's like shopping at Costco or Sam's Club or those warehouse kind of stores. You ever shop there? You buy in bulk, right? You can't buy like one milk. You go grab one milk, it's plasticed to another or to maybe to 3 more. You buy them in groups of 2 or 4 or something like that, right? You can't take your scissors to Costco and just clip the plastic and go, thanks, I just want one, right? That's the whole deal with the warehouse stores. You buy a lot. We have 5 kids. My wife shops at Costco. You buy a lot, and you get a cheaper deal, right? So that's what pluses and minuses are like in algebra. They glue things together, make it a package deal. You buy the whole thing or nothing. Pluses and minuses. do that. They function like glue. So I can't do that, right? Because it means you either cancel the whole 6w minus 54, the whole thing, or nothing. You can't just take part of it. You can't say, I just want the 6w, thanks, that's all I want. You can't do that. Okay, so, well then what I do, nothing? No, there is one thing you can do. If I could just make that top into multiplied instead of subtracted, times, then you can cancel. Multiplied things, no problem, cancel them. But the plus and the minus, that's the problem, it glues them. So how do you turn that top into two things multiplied? You factor. That's what factoring does. It makes it multiplied, right? Now let's take out the GCF, right? What goes into 6 and 54? 6 does, huh? Yeah. And then what goes on the inside? 6 times what? Well, W. And 6 times what? 9. 6 times 9, right? The bottom, no change. See how we've made it times now? We've made it 6 times something. Okay, great. Why is that so great? Well, now we can cancel just the 6, right? Because the one on the bottom is not glued. The one on the bottom is times, so he's fine. That's just shopping at Save Mart or Vaughn's or something. You can buy just one. It's okay when they're times. You can take just the 6. That's fine. You don't have to take both. They're not glued. Makes sense? So what are we left with then? W minus 9 over W. You don't need those parentheses on the top anymore because there's nothing to separate it from anymore. It's not necessary. The 6 is gone. And that's our final answer. We're done at this point. We cannot, why can't I cancel these W's? The glue thing again, right? Pluses and minuses, glue. The top, you buy the whole W plus 9 or you don't touch it, right? It's all or nothing. And so we're done. Does that make sense? We factored. That's what made it times so we could cancel. Is that good? Questions I can answer? All right, we'll try another. So I'm going to make those x's 9x squared plus 9x over 72x squared plus 81x. So they want me to simplify that. Can I just start canceling things? Can I go like, 9 goes into 81, 9 times, cancel the x's, and 9 goes into, no, right now they're glued. They're package deals, meaning if you want to do something up here, you go like that or you do nothing. You buy the whole package or you don't touch it, right? All or nothing, well, I can't cancel the whole thing. So what do I got to do? Factor, right? See how these are just all going to become factoring problems because that makes it multiplied. That's what factoring is. It changes it to things multiplied, and then we can cancel just part of it. So yeah, so go ahead and factor the top, factor the bottom. It's like 2 factoring problems. That's pretty much what all these are going to become, is 2 factoring problems. So factor the top, take out the GCF. So what is the GCF on the top? 9 and x, 9x, good. Is that good? They have 9x in common. What does that leave? 9x times x, 9x times 1. Good there. Now on the bottom, what's the GCF on the bottom? Oh, that's a 72. I think it's a 12. Yeah, right, 9 then. 9 and x again, huh? Right? So, that good? So 9x times 8x, 9 times 8, 72. 9x times 9. Yeah.
Could you put like the 9x on the outside of the whole fraction? Like just 9x times the entire thing? Or does it have to be on both the top and bottom?
Put the 9x in the front like this?
Yeah.
Well, if you put 1 out front, that means over 1, that means in the top.
Oh, okay.
Yeah, anything alone, remember, is in the top, really. So that would work for the top one, but you still have to have the bottom 9x as well. Yeah, so we should just leave them where they're at. So is that good on the factoring so far? And now, that's the hard part, huh? Because now the canceling's easy. Once you got them factored, right? We can cancel the 9s and cancel the x's, right? That's fine to do. Cancel those out because they're just times. They're just multiplied. So it's okay to get just them. So what does that leave? X plus 1 over 8x plus 9. And we're done. You don't need the parentheses anymore. There's nothing to separate them from. You can't cancel the x's or anything else because these are glued packages, right? So there we go. Is that good? Is that making sense? Pluses and minuses glue things. Why does math make up all these hard rules like this? Pluses and minuses glue things, and you've got to worry about the glue bond all the time, but times doesn't, and you can cancel that. That makes the rules hard. You got to constantly worry about what kind. And what's the answer to that? Why math makes up the rules, the hard rules like this? Remember what I've said? Job security. I need a job, so we made the rules hard. I'm just joking around. What's the real answer? Why does math make the rules hard? What's the end? Every time I answer that question, it's the same answer. Because it's the truth, right? Math is just following the truth. So notice what I'm saying to you. Let me, because I don't want to just give you rules. To me, that's boring. Maybe you feel a little bored. Let me make it, I think, more interesting is why. I'd be out there thinking like, why? Why? Why this weird plus rule, times rule? Is that really true? True. Is that true? So what I'm saying is pluses and minuses cannot cancel things. They're glue. Times you can. So let me show you with a simple example. How about if we took 2 plus 8 over 2? Right? That's added, right? Now, what I'm saying, if I was you, I'd be thinking, you're telling me, Mr. Aaron, you're telling me that you can't cancel those 2's. It's wrong. But if it was times, it would be okay? Exactly. It's exactly what I'm saying. Let's prove, let's just look and see that it's not just some little funny thing math is doing, it's just the truth. Look at this for a minute. Forget about the canceling thing, just pretend, we're not going to do that. And let's just go back and say, okay, what is this thing really? 2 plus 8 over 2. Isn't that really 10 over 2, which is 5? I mean, that's really 5, right? All fancy rules aside, that thing's a 5, right? So you see that if you cancel the 2's, it becomes 8, and that's just wrong. See how it's not just my opinion or some math teacher's opinion or some math book statement. That's just wrong to cancel those 2's. But down here, it's okay? Yeah, it is. Look at it. What is it really? Isn't it really 16 over 2? Which is really what? 8. So is canceling the 2's okay? Mm-hmm. So, see, that really is the truth, isn't it? It's just simply true that when you have times, it's okay to cancel. You don't mess the thing up. You don't change the answer. But if they're added, subtracting would also not work. And you cancel, you changed it. It's 5. It's not 8. It's just not true, huh? So math is just following the truth, like a hound dog following the scent wherever it goes. That's just the truth. Pluses and minuses are like glue. You can't cancel things. You'll lose the truth. Times is no problem. That's just the truth. All right. So can I move ahead on that? Any questions or comments? Is that good? So basically the rest of this section, it's all going to be 2 factoring problems. Factor the top, factor the bottom. And you guys, since we have our test today, are lean, mean factoring machines, right? You're ready to go. So this, I think that's probably true for most of you. And this will be a pretty easy section. So that one is p squared minus 81 over p squared minus 18p plus 81. Plus 81 down there. So basically, same thing, pluses and minuses glue. So you have to factor the top, factor the bottom. It's like 2 factoring problems. So can you do that? Factor both the top and the bottom. Then you can cancel. So the top is an FL, isn't it? We good with that? P plus 9, P minus 9. The bottom's a FOIL. So it's the 2 parentheses, P's in the front. What multiplies? You know, multiplies to be 81, 9 and 9. How do you make minus 18 in the middle? Both negative, huh? Is that good? Both negative? And then we can cancel, huh? Because I'm buying the whole glued package. That's fine. I'm not breaking any glue bonds. I'm not taking any two things added and just taking part of it. So that's correct to do. So what are we left with? P plus 9, or, you know, these two are left over, right? Don't need the parentheses anymore. There's nothing to separate them from anymore. That's just the answer. I can't cancel the P's. I'd be breaking the glue bond, right? So that's just it right there. Does that make sense? Are we good with that? So it's just factoring, isn't it? Just bunch factoring. This chapter. This section, anyway. Is that good? I'll move on if you're okay. So W squared plus 9 over W plus 3. So do that one. Factor the top, factor the bottom. How you doing? I hope you're doing nothing, because you shouldn't be doing nothing. Why? What am I talking about? What's up with this one? This one's an FL, right? Yeah, it's an FL, but it's an FL plus. What does that mean? Not factorable, yeah. Right? You can't factor that. Remember, so this is like a little test. Do you realize you cannot factor FL plus? Really important for today's test, right? There'll be 10 factoring problems. Probably a couple of them have some FL pluses. You cannot factor FL plus. If that was W squared minus 9, I would totally do it. You might be thinking, I know some people usually are thinking, I did for a long time before I learned, isn't it W plus 3, W plus 3? No, it's not. It looks good, but that's not right. Let me prove it to you. Let me check it real quick, if this helps you at all. W squared plus 3W plus 3W plus 9. See how you get a 6W in the middle? That's not the same as W squared plus 9. That's just not right, huh? Do you see how it's not W plus 3, W plus 3? That's not true. That W plus 3, W plus 3 would put a 6W in the middle, which is not what we originally had. That's not right. Does everybody see that? You just can't do the plus. The FL plus cannot be done. If that was minus in the middle, W squared minus 9, totally, I would do, W plus 3, W minus 3. And a lot of people think, okay, well, with the plus 9, just do both plus. No, not true. That would put a plus 6 in the middle. So anyway, so the answer is just that. Here, see the answer? It's the same as the question. There's nothing you can do. It cannot be simplified. Is that okay? They're just testing that. Making sure you know that can't be factored. We good? Especially today's test, you need to know. There'll be some FL pluses. Don't factor them, right? They're not factorable. All right. So we have 8 S plus 40 over S squared minus 5S minus 50. Try that one. Factor the top and factor the bottom. So the top's just a GCF, right? Take out what's in common on that. Is that good? Top's just to take out an 8, like that on the top. Leaves S plus 5. Is that good? Can you tell my 5s from my S's? I don't know why they always put 5s in problems with S's. Is that good up there? Right? Because, 8S and 8 times 5 be 40, right? And the bottom, factor the bottom, the FOIL. So we do 2 parentheses. This is in the front. Okay, so what multiplies to be 50? Well, 5 times 10, huh? Make that 5 a little more 5-ish. There we go. 5 times 10. And then the sign in the middle? Sign in the middle goes on the bigger, doesn't it? This is plus. Plus 5 minus 10 makes minus 5 in the middle, huh? Good. And now that it's factored, now we can buy the plus to minus glued packages. That package and that package. We're buying the whole package, so it's good. What are we left with? 8 on the top, S minus 10 on the bottom. Can I reduce the 8 and the 10, divide them both by 2? No. Those bottom's a package deal. If you want to mess with the bottom, you buy the whole bottom or you don't touch it, right? It's all or nothing on the bottom. It's glued together like shopping at Costco. So we're done. We can't buy the whole thing, so we buy nothing. Is that good? These all making sense? Really, it's factoring again, huh? That's why I was saying, it's good that you master factoring, because then pretty much through the rest of the course, it's just everything we begin with, pretty much this point forward, is factoring. They all just start with factoring. So it's good if you're getting good at factoring. Okay, so this problem is 4 minus x over x minus 4. It's the same thing, just reverse ordered. So how should we do it? Well, basically, I'm going to give you a special rule to make it easy. Should we do it that way? Yeah. Let me just write it that way. So, yeah. If I switch the order, of the things on the top, what'll happen? Remember when you move things around, you're supposed to take your baby with you, right? That the sign that's in the front of them goes with them wherever it goes. So that minus that's on the x is going to go with it. Well, I should say, first off, I'm having a problem because the order's different, right? I don't like the x's in the back. So I want to flip that around. So I'm going to put the minus x, see that minus went with the x to the front. And what was in front of that 4 all along? Nothing, which means plus, huh? So far, so good. That was just changing the order on the top so the x's are in the front. Good? So far, that's just reorder them. Take their sign with them, though, when you move them. Right? Take their baby with them. Okay, now, I'd like to cancel those things, but their signs are different. Is there something I could do on the top to help that?
Factor -1.
Yeah, you could factor out. Remember how whenever we have negative in the front of x, in the very front term, we always factor out a -1? And what does it do on the inside? Changes the signs. Remember all that stuff? So it becomes x minus 4. So now it matches the bottom. See how that's right? Because minus 1 times x will go back to minus x, and minus 1 times minus 4 will go back to plus 4, huh? Y'all see that okay? See how that's right? Let me slow down there and let you digest that for a second. Do you see those two steps? So first off, we don't want x at the back. So let me write a note about that. When x at the back reorder, keep signs in the front, keep their baby with them. So whenever you have X at the back, you reorder them. You don't want X at the back, you want X at the front. But reordering, you take your sign with you when you go. You take your baby with you, right? Whatever sign's in the front. So then this is factor out -1, signs change. All signs change, right? Whenever we have negative in the front, we factor out -1. Now, after doing all that, we can cancel now, can't we? Now they match. So what are we left with? Just -1. That is the answer. Just the -1. That means all of this is a fancy way to say -1. It boils down to just being -1. Does that make sense? You know what we're saying? Sometimes I think we do so much of this kind of algebra stuff, and maybe it doesn't make very much sense what we're even saying. When I'm saying, or we're saying, what we just showed with the laws of algebra, that 4 minus x over x minus 4 ends up being -1, right? That's what we just showed. That means whatever x is, remember x is a variable, can vary, can be any number, right? That means 4 minus any number over that same number minus 4 will always be -1. That's what that's saying. Let's see that. Is that true? Doesn't seem right. Meaning, if I go like 4 minus 10 over 10 minus 4, right? If I, instead of x, I'm letting the x just be 10, right? I'm just saying, hey x, you're 10 in both places, right? So is that really -1? Well, what is 4 minus 6? What is 4 minus 10? It's -6. And what is 10 minus 4? It's 6. And what is -6 over 6? -1. Well, really? Okay, what if I made it 11? Does that really work for any number? What if I made this x 11? Yeah, x is a variable. X can be any number. So what would that be? Well, now it would be -7 over 7. Still -1. See, it's true, isn't it? We proved that 4 minus any number over that number minus 4 is always -1. That's what we just showed.
If it's positive over negative, it is the same.
Yeah, positive over negative is still negative in the end. Yeah. Yeah, you're thinking like if you let it be a small number, like 2 or 3? Is that what you were thinking? Yeah, it would still, yeah, because positive or negative is still negative, yeah. If I let it be, let's say I let it be like 1. How about 4 minus 1? That would now be 3 over -3, and positive over negative, still negative, -1. Yep, it's always true, isn't it? That's what we showed. That's what we're doing with algebra. We're showing what's true for all values of x. This is always -1 for all values of x. All right. Okay, so 5z minus 45 over 9 minus z. Okay, so which one should we reorder there? Which one is not in a good order? The bottom, right? The denominator, right? You don't want the letters at the back like that. So reorder. So reorder that denominator, and then factor out the -1. With me? So that minus on the z and really nothing, so plus on the 9. We're going to reorder. So we get minus z plus 9. We good there? So now we have the letters in the front. That's what we like it. Now can you factor? Factor the top, factor the bottom. Out 5. What about on the bottom? How do we factor the bottom? Factor out the -1, huh? Whenever there's a negative in the front, factor out a -1. And that changes the signs, doesn't it? Because -1 times e would go back to -e, and -1 times -9 would go back to +9, huh? So that's correct factoring, right? Whenever you factor out a -1, it changes all the signs inside, doesn't it? Everybody see that? And now we can cancel. So what's the answer then? 5 over -1, what's that? Yeah, it's just -5. Right, because positive over negative is negative, and anything over 1 is just itself. So it's -5. Which means what? All of this is a fancy way to say -5. Questions on that one? Are we good? All good? Okay. I'll keep moving. Number 18. 9 z to the 9th over 7z times 2 over z. All right, we're multiplying a couple fractions. So you guys know the rules, huh? What are the rules when you're multiplying two fractions?
Common denominator?
Well, that'd be for adding, subtracting. Yeah, we'll do some of that today. When you add, subtract, yeah, that's a good point. You need to make common denominator, huh, when you add or subtract two fractions. But if you times them, you can just cross-cancel, huh? What I would suggest with the cross-canceling, I think the easiest thing, is just count the total number of z's, top and bottom, and then just subtract, huh? So we have 9 z's on the top, clearly. Up here, there's 9. Down here, this is z squared, really, isn't it? So really, the 9 minus the 2, it's z to the 7th on the top, when the 9 minus 2 subtracts. And then the other numbers that are left over, 9 times 2 is 18 over 7. We're done. Are there questions on that one? All right, I'll move on if you've got that down, if you're okay. You know, I would have cross-canceled those numbers, like if 2 went into 7, I would have, but 2 just didn't go evenly into 7, huh? So you cross-cancel if you can, but if you can't, you just multiply straight, top, right? I just did straight, top with top, and the bottom is by itself. Okay. Three z to the 5th over 11r cubed times 121 r to the 5th over 9z. So, can you cross-cancel the letters and the numbers? Go ahead and cross-cancel. You're allowed to cross-cancel on that one. Use your calculator if you're rusty on some of those. So 11 goes into 121 11 times. If you're not sure, you just calculate 121 divided by 11 is 11. And 3 goes into 9 3 times. We good with all that? So what are we left with? We have 11 on the top, 3 on the bottom. And then z to the 5th over regular z. Those powers subtract, don't they? Z to the 5th over z to the 1 is going to leave z to the 4th on the top. We good with that so far? Am I losing you? And then r to the 5th over r to the 3rd, powers subtract r squared on the top. And there we go. Questions on that one?
So everything just goes on top?
Well, in this case it does because the bigger powers were on the top. It's a good question. Yeah, see how the z to the 5th is bigger than the z to the 1st. So the bigger z is on the top. Yeah, and then the r to the 3rd, the bigger one's r to the 5th on the top. So if the bigger power had been on the bottom, the answer would be on the bottom. Yeah, remember the answer always ends up wherever the bigger power was on that. Yeah, so if I had like r to the 5th on the bottom and r to the 3rd on the top, that would be r squared on the bottom, wouldn't it? Is that good? Good question. Other questions? Is that okay? Okay. So, z squared minus 25 over z squared times z squared minus 5z over z squared plus z minus 30. All right, so that's kind of like 4 factoring problems. Well, I guess just 3 because the z squared itself doesn't need to be factored. But there's 3 factoring problems, isn't it? So go ahead and factor those. So you factoring those okay? So z squared minus 25. So we factor that. That's an FL, huh? And it's an FL with a minus, so we can do it. If that was, what if that was z squared plus 25 up there? I would just leave it, huh? It wouldn't be factorable. But the minus is doable. Only the FL minus. So we got z plus 5 and z minus 5 over z squared. And how about this one up here? How do we factor this one in the upper right? How do you factor z squared minus 5z? Yeah, it's take out the GCF. Does everybody see that okay? Yeah, take out the z. They both have a z, huh? Is that good? Leaves z minus 5. That's correct. How about the bottom down here? Well, it's a FOIL kind of thing, huh? So 2 parentheses, z's in the front. What multiplies to be 30? 5 times 6, yeah. And then in the middle is a +1, really, huh? So the sign in the middle is positive, and that goes on the bigger, huh? So +6 minus 5 is +1 in the middle. So that's good. We good? And now that's the hard part. It's all that factoring, which you guys are pretty good at already now. And now we can cancel. Now, when it comes to the canceling, should I cancel this z minus 5, the left, upper left, lower right, cross cancel the z minus 5? Or should I go straight up and down, or do you do both? Well, you do either one. You don't do both. But really, you can do whatever. So I'll just do these two. It doesn't matter, just anything in the top with anything in the bottom, either straight up and down or diagonal, it doesn't matter. Just top to bottom, cancel out. Anything else we can cancel there? What's that? Yeah, good job. This cancels one of these, leaving z to the first, huh? See, because what does z squared really mean? 2 z's. So one of these cancels one of these, and there's one left over on the bottom, huh? Like that. Is that good? So now I think we're about done. What is it? Everything else is left. So what's left? Well, on the top we have z plus 5, z minus 5, still left over. On the bottom we have plain z and z plus 6. And there we go. Yeah.
But couldn't you have just taken out the first fraction?
What do you mean taking out the first fraction?
The z squared and the z squared on the bottom.
Uh-huh.
Couldn't you have just taken that out?
Oh, gotcha. So that first fraction, really good question. Yeah, just like that, just cancel those.
Yeah.
What do you think? Can we do that? The glue rule. Remember the plus or minus? Yeah, when things are, you can't do that because when things are added and subtracted, they're glued together. So you cannot cancel just those z squared. Why? Because this one up here, this z squared minus 25, he's glued together, which, like shopping at Costco, you can't take just one of the milks, right? Which means you either buy the whole package or you don't touch it. You can't say, I want just this part, please. No, this right here is gluing it to the 25. They go together. It's all or nothing on that. So plus and minus things are attached, which means they go together. You either take them both or you don't touch them. You can't break that glue bond and take one part of an added subtracted thing. So that's why we instead have to factor like that. Is that good for everybody? Is that making sense on that? Other things I can answer on that? All right, we're close. See, we've got, I'm going to make it x. I'm getting tired of those s's. X to the 4th minus 16 over x to the 4th minus 81 times x squared plus 9 over x squared plus 4. Try that one. So factor. I can't cancel right now because they're all glued, right? But go ahead and factor. So it's an FL, huh? So the FL minus, remember the rule with two terms, FL. FL minus, you can do it, huh? So x squared's in the top, 4's 1 plus 1 minus. On the bottom, nines, 1 plus 1 minus. Is that okay? See how I did both those FL minuses? Now over here, this is an FL plus, and so is this one. This one was an FL minus. So what's the story with these two FL pluses? Have to stay the same, huh? Can't be factored. Is everybody okay with that? Is that making sense? Like that? That good so far? See how those FL pluses have to stay the same. They can't be factored, right? That x squared plus 9, that's not x plus 3, x plus 3. That's not. It's not true. Is that okay? That even on today's test, that'll be important, that you know that FL pluses have to stay that way. They can't break down, but the FL minuses do. Okay, at this point we can cancel stuff, can't we? Right, everybody see that? So we can go x squared plus 9, x squared plus 9. You might say, well, what about the plus? Well, yeah, I bought the whole package. That's okay. Costco will let you buy the whole package. You just can't buy part of the package, right? It's a glued package. You buy it all or nothing. See how I'm taking it all? I'm not just taking the x squared or just taking the 9. I'm taking the whole package with the whole package. So that's fine. And then here, the x squared plus 4 with the x squared plus 4, whole package. That's fine. So what's left over? X squared minus 4 over x squared minus 9. That's our answer. I can't cancel these x squareds, again, because that'd be taking part of a package. These are packaged together, glued together. So that's just it right there. Now, some of you may have factored it further. Maybe you went and said, hey, well, Mr. Aaron, that's an FL minus. I can go further. You're right. That's okay, too. You might have said, well, I made it x plus 2, x minus 2, and the bottom is x plus 3, x minus 3. Yeah, you're right. That's okay. You can do that. That's a fine answer also. That's also the true answer. Nothing else cancels, huh? So either one of these is fine. They're both right. If I was you, I'd kind of wonder. I'd be going like, wait a minute, don't you have to factor? I mean, aren't we supposed to simplify it? Well, the answer to that is really factoring is only required, like absolutely necessary, if it makes something cancel. Because that's really our goal, is to get things to cancel. Get simpler by canceling. And see how nothing cancels? So really it's okay to leave it this way. Because when we broke it down, nothing canceled. So this isn't really better. Both, they're equally fine. Either one's good. How are we doing? Is that making sense? Questions I can answer on that? Let me know. Let me know if you need me to speed up or slow down. All right. So I think